Assalamu alaikum. We know when a gas taken in a tube is heated, it emits out the electromagnetic radiation of a definite wavelength. Why it happens? What is the reason behind it? When we heat a gas or due to electric discharge inside the tube which carry gas, electrons present in the atom of that gas gets excited. They move from lower energy level to the higher energy level. They stay in the higher energy level for a certain period of time. When they return back to the lower energy level, they emit out a radiation which forms spectral lines. Here, the wavelength of this spectral line depends on the energy levels between which the transition takes place. So this is how we get the different wavelengths which constitutes spectral series. In this video, we'll discuss the spectral series of hydrogen atom. Now before that, let me explain the formation of spectral line with the help of a simple diagram. Now, already I have told you, when we talk about an atom, it consists of electrons revolving around the nucleus in orbit. According to Niels Bohr, electrons revolve in circular orbit around a positively charged nucleus. Okay. Here, this orbit is otherwise referred as energy level. When we supply heat or when we supply some energy from outside to the atom, these electrons absorbs them. As their energy increases, what they do? They move to a new energy level. Suppose if I have one more energy level here, then these electrons will move to that energy level. Here we call this energy level as excited energy level, and this energy level which is very close to the nucleus is referred as lower energy level or ground energy level. Okay, this is what happened here. Now these electrons now referred as excited electrons. When they move to the higher energy level, they stay there for a certain period of time. When they return back, they emit out the radiation. Whatever excess energy that they have is emitted out. Okay, let me show this to you here. Suppose this is the first energy level, and this is the higher energy level. An electron is present here. Now I supply energy to this electron. This electron absorbs it and moves to the higher energy level. Now this electron is referred as excited electron. Okay, when it returns back to the lower energy level, now the difference in the energy between these two levels is emitted out in the form of radiation. So it emits out the radiation. Clear? This is how we get the spectral lines. Understood? And here the wavelength of the spectral line that we obtain here is given by this equation. 1 upon lambda equals to R multiplied with the 1 upon n square minus 1 upon m square. Now this is the expression obtained from Bohr's atomic model. Okay, and here R stands for Rydberg's constant. Here R stands for Rydberg's constant. Rydberg's constant. And it has got a value equal to 1.097 into 10 power 7 per meter. Per meter is a unit of Rydberg's constant. And apart from this, Here m and n are positive integers. They're just numbers, positive numbers. M and n are positive integers. Fine, and we know what is lambda stands for. Here lambda is nothing but wavelength. And for your kind information, reciprocal of wavelength gives us wave number. We take the reciprocal of this. What you obtain is nothing but wave number. This is wave number. Wave number. Number of waves in a given length is the wave number. Okay. Fine. Now we'll discuss the spectral series of hydrogen atom. And I told you here the wavelength of the spectral line depends on the energy levels between which the transition takes place. Okay. Hydrogen spectrum have got 5 spectral series. First one is Lyman series. Lyman series. When the transition takes place between any one of the energy level to the first energy level. Suppose, let me clear this. When electron from any other energy level jumps to the first energy level, it gives or it produces Lyman series. Okay. When electron jumps to first energy level from the outer energy levels. Here M stands for 2, 3, 4 or any energy level. Okay. And one thing I forgot to mention here. Here the value of M is always greater than N. Okay. It is always from the values. Okay. So if I substitute the value of M and N in the above equation, what do I get? I get this 1 upon lambda, which is nothing but wave number. So wave number equals to R multiplied with, in the place of N I write 1. The square of 1 is 1. Okay. Minus 1 upon M square. Here I do not take the value of M in this equation because it has got multiple values. Clear? So this is the wave number obtained when we substitute the values. Okay. It is found that Lyman series lies or falls in UV region. It falls in UV region. UV region. The spectral series falls under UV region. Okay. Next one is Balmer series. Second one. This first one. Second series is named as Balmer series. When electrons in the hydrogen atom jumps from any other energy level to the second energy level, then we obtain Balmer series. It's too simple. Here, transition takes place. From any other energy level to the second energy level. Okay, so the next number 2 is nothing but 3, 4, 5. It goes like this. So on substituting the value, we obtain the wave number as mu bar equals to R multiplied with 1 upon 2 square. Here the value of n is 2 minus 1 upon m square. This is what we obtain. Okay. I will simplify this and write here. So mu bar equals to R multiplied with 1 upon 4 minus 1 upon m square. Got it? And here, this spectral series is a visible region. Is a visible region. Understand? The third one, passion series. That is passion series. When electrons from outer energy levels falls to third energy level, then we obtain passion series. Okay. So when electron jumps from any other outer orbits to the third orbit or third energy level, we obtain passion spectral series. So here is 4, 5, 6 and goes. So I'm going to substitute the value of m and n in this equation. Okay. Let me name this equation as the equation number 1. So by substituting the values in equation number 1, I obtain the wave number as nu bar equals to r multiplied with 1 upon 3 square minus 1 upon m square. Okay. Now, let's simplify this and get the value. To be equal to 1 upon 9 minus 1 upon m square. This is the expression for wave number. And here, passion series falls under infrared region. Falls under IR region or infrared region. Okay. Then fourth series, Lyman Balance passion bracket series. Yeah. When electrons from outer energy level jumps to fourth energy level, we get a bracket series. Okay. So n is taken here, 4 here, and m is nothing but 5, 6, 7. It goes on. So the wave number r multiplied with 1 upon square of 4 minus 1 upon m square. Okay. Then on simplification, we get the value as 1 upon 16 minus 1 upon m square. And it is found that bracket series falls under infrared region. Okay. So these are all the spectral series of hydrogen atom. There is one more left that we will discuss now. Let me tell you how do we get the fifth series of hydrogen spectrum. The fifth series is named as Fund series. Fund series, P is silent. Fund series. When electrons from outer energy level jumps to fifth energy level, then we obtain Fund series. The spectral lines obtained falls under Fund series. Okay. Here n is taken as 5 and m is next numbers, which are nothing but 6, 7, 8 and so on. Okay. And the expression for wave number is written as r multiplied with 1 upon 5 squared minus 1 upon m square. Understand? And here, when we simplify this, we obtain the expression as nu bar equals to r multiplied with 1 upon 25 minus 1 upon m square. This is the wave number. And here front series also falls under infrared region. This spectral series also falls under IR region or infrared region. Okay. Before I conclude, let me write all these things in a table column. I'm going to simplify all these things. Here actually I should mention one more T here for bracket. Okay. So for this I'll take a then value of n, after that value of m, then wave number, which is the reciprocal of lambda. At the end, the region where the spectral series fall. First series is nothing but Balmer series. Balmer series. Here, when electrons from outer energy level jumps to the first energy level, we get this series. Here, the value of n is 1. And m is 2, 3, and so on. And the value of nu bar is nothing but r multiplied with 1. 1 upon 1 is 1. So I have to write here this way. 1 upon m square. And here this falls in UV region. UV region. UV region. This is all about the Balmer series. The second one is Lyman series. Okay, so I made a mistake here. The first one is Lyman actually. Lyman series. The first series is Lyman. The second one is Balmer series. To get to the Balmer series, electron jumps from outer energy level to the second energy level. So n is taken as 2, m is taken as 3, 4, and goes this way. Okay. Then the wave number here is written as nu bar equals to r multiplied with 1 upon 4 minus 1 upon m square. Okay, and this falls in visible region. Okay. The third one is a passion series. Here the value of n is 3, and here it is 4, 5, and so on. And the wave number is nothing but this r multiplied with 1 upon 9 minus 1 upon m square. Okay, and it is in infrared region. Now fourth one is a bracket series. Bracket series. Here the value of n is taken as 4, and the value of m is taken as 5, 6, and so on. The wave number is represented as r multiplied with 1 upon 16 minus 1 upon m square. Okay, and this also fall under infrared region, IR region. Last one is fund series. Here the value of n is taken as 5. Remaining values are 6, 7. Value of m. The next wave number is represented as r multiplied with 1 upon 25 minus 1 upon m square. Clear? And it falls in infrared region. Okay, this is how I have tabulated the series one by one. Okay. Fine. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your questions in the comment section. Thanks for watching.